This is SpaceTime, Series 25, Episode 22, for broadcast on the 21st of February 2022. Coming up on SpaceTime, a new insight into Earth's inner core, exploring the secrets of the stars of the Southern Cross, and Astra Space fails in its latest attempt to get a satellite into orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Earth's core, the deepest part of our planet, is characterized by extremely high pressures and temperatures. It's composed of a liquid outer core and a solid inner core. The inner core is formed and grows through the solidification of liquid iron at the inner core boundary. Previous studies have shown that the inner core is less dense than pure iron, and some light elements are believed to be present. But there are still a lot of questions to answer. Now, a new study suggests the Earth's inner core isn't completely solid, but instead is composed of a solid iron sublattice and a mixture of liquid-like light elements in a superionic state. A superionic state is a sort of intermediate state between a solid and a liquid, and in the case of the Earth's solid inner core, it's highly diffuse in iron sublattices under the sorts of extreme pressures and temperatures which exist in that environment. The findings, reported in the journal Nature, are based on new high-pressure and high-temperature computational simulations using quantum mechanical theories. The authors found that some iron-hydrogen, iron-carbon and iron-oxygen alloys transformed into a superionic state under the sorts of high pressures and temperatures which exist in the Earth's inner core. In superionic iron alloys, light elements become disordered and diffuse, like a liquid in a lattice, while the iron atoms remain ordered and vibrate about their lattice grid, forming a solid iron framework. One long-standing mystery about the inner core is that it's quite soft, with a low shear wave velocity. And so the authors calculated the seismic velocities in these superionic iron alloys and found a significant decrease in shear wave velocity. And so the theoretical results fit in nicely with seismological observations. The authors say it's the liquid-like elements which make the inner core soften. That's because the highly diffuse light elements can affect seismic velocities. In the process, they're providing critical new clues for understanding other mysteries about the Earth's inner core. This is SpaceTime. Still to come, exploring the secrets of the Southern Cross, and Astra Space has failed in its first launch attempt from Cape Canaveral. All that and more still to come on SpaceTime. Astronomers have used a new technique to unlock some of the secrets of the interior structure of Beta Crucis, the second brightest star in the constellation Southern Cross and the 20th brightest star in the night skies. The Southern Cross is an important symbol featured on the flags of many nations, including Australia, New Zealand, Brazil, Papua New Guinea and Samoa. The new findings, reported in the journal Nature Astronomy, suggest that Beta Crucis is some 14.5 times the mass of the Sun and just 11 million years old, making it the most massive star ever whose age has been determined using astroseismology and polarimetry. Astroseismology studies seismic waves reflecting off the stellar interior, producing measurable changes in light, while polarimetry measures the orientation and polarization of the electromagnetic light waves. Beta Crucis is a triple star system located some 280 light-years away. The primary star, Beta Crucis A, is a Beta Cephei variable star. Beta Cephei variables, also known as Beta Canis Majoris stars, are variable stars that exhibit small rapid variations in their brightness due to pulsations of the star's surfaces, which is thought to be due to the unusual properties of iron at temperatures of over 200,000 Kelvin in their interiors. The secondary star, Beta Crucis b, is a blue-white spectral type B main sequence star, while the third companion is a low-mass pre-main sequence star. One of the study's authors, Professor Jeremy Bailey from the University of New South Wales, says probing the interiors of massive stars that will later explode as supernovae has traditionally been difficult. Bailey and colleagues wanted to investigate an old idea first proposed back in 1979, but one not possible to explore until now, namely that polarimetry had the potential to measure the interiors of massive stars. But the size of the effect is quite small, so Bailey and colleagues ended up needing to design and build what's turned out to be the world's most precise polarimeter in order to carry out the research. The study combined 3 different types of measurements of the light from Beta Crucis. There were space-based measurements of light intensity from NASA's WIRE and TESS satellites, 13 years of ground-based high-resolution spectroscopy from the European Southern Observatory, and ground-based polarimetry gathered from the Siding Spring Observatory in outback Western New South Wales and the University of Western Sydney's Penrith Observatory. To carry out the research, the astronomical polarimeter was attached to the 4-metre Anglo-Australian telescope at the Siding Spring Observatory, and then operated while NASA's TESS Space telescope was observing the star. Analysing the 3 types of long-term data together allowed the authors to identify the star's dominant mode geometries. And that in turn opened the way to weighing and age dating the star using seismic methods. The use of polarimetric studies in this project opens a new avenue for astroseismology of bright massive stars. While these stars are the most productive chemical factories in the galaxy, they're also the least analysed astroseismically, given the degree of difficulty of such studies. Bailey says the findings will provide new details on how stars live and die and how they impact the galaxy's chemical evolution.
So Beta Crucis, also known as Mimosa, is one of the 4 stars in the Southern Cross. It's actually the second brightest one, and it's a massive star. And with stars, a high-mass star also means that it's a hotter star. These stars use up their fuel, their nuclear fuel, the hydrogen that they burn, much faster than a star like the Sun. And because of this, they put out a lot of energy, and they have relatively short lives, which means they go through their evolution, probably explode as a supernova, and they return material to the interstellar medium, which can make the next generation of stars.
Astronomers like to call these things the James Deans of the stellar world, don't they? Live fast and die young.
That's right. But that means that for the evolution of a galaxy as a whole, these are really the most important stars because they're providing the fuel to make the next generation of stars.
And with this particular star, you've been able to determine its age to a pretty accurate degree, 11 million years. Tell me about it.
Yes, that's right. So what we're using is a technique called astroseismology. So what we need to do is look inside the star because you can't really measure the age of the star by just looking at what's going on its surface. What happens as a star ages is that it's the inner regions of the star, the core where the nuclear reactions are going on, is changing. And that's difficult to observe. But this technique of astroseismology effectively allows us to look inside a star. So it's essentially the same technique as seismology as used by geologists to look inside the Earth. And it works because there are waves propagating within the star that essentially bounce all the way into the center of the star.
And when you look at the star, is that like almost a Doppler shift type effect on the stellar surface? Is that what you're sort of interpreting?
That's one of the ways of doing this astroseismology. So there are 2 ways that astronomers usually look at these oscillations. One is you can see the brightness of the star changing. So that's called photometry. And the changes in brightness of the star are usually quite small. So this is something you usually have to use a space telescope to observe in order to get sufficient precision. Another way of doing it is, as you said, by looking at the Doppler shift, looking at the radial velocity, the velocity variations, the surface of the star moving in and out. And what's new about our work here is that we've, for the first time, applied a third technique for looking at how stars oscillate. And that's measuring the polarization of the starlight.
And this is the instrument you've developed?
Polarimeter, yes. So a polarimeter is an instrument that measures polarization, and effectively what it allows us to see is the star changing its shape. So when these stars pulsate, so one type of pulsation you could imagine is the whole star just changing its size. That's called a radial pulsation. But what we're looking at is, and what is common in many stars, is what are called non-radial pulsations. So that's the star actually distorting its shape and becoming non-spherical. That non-sphericity is what we measure with a polarimeter, because that causes the light to become polarized.
Do you have to look at this over a long period of time in order to get that reading? Because often a star will have a more elongated shape if its rotational rate is fast.
Yes, that's another type of observation we can make with a polarimeter, is measure stellar rotation. But that's a fixed configuration. What we're seeing here is oscillating asymmetries in the star. So, but yes, you have to observe it over sufficient time to see those changes. The periods are a few hours, and so you really need continuous observations over. Well, ideally, we'd like to observe it continuously for several days. We can do that with the space telescopes that do the photometry, but obviously we can only observe at night, so we get breaks in our observation. But nevertheless, we can get enough coverage from many nights on a telescope to see what's going on. So what we've done in this work is actually put together these three techniques of studying the oscillations. So we've used observations from the TESS spacecraft that does photometry. We've used a long series of spectroscopic observations, but adding in the additional information we can get from the polarization is what's enabled us to develop a detailed model for what these oscillations are doing, and then use that to make inferences about the interior of the star, which is what leads to the mass and the age and so on.
Based on the observations, what's happening to this star now? Has it got much longer to live before it starts to expand and begin the process of becoming a supernova?
Yes, I mean, it's a relatively short-lived star compared, the sun. The sun we know is something like 5 billion years old, and it's got another 5 billion years to go. This star will go through its evolution much, much quicker, a few more million years maybe, before it becomes a supernova.
And this technique that you're using on Mimosa, it can be used on pretty well any star, can't it?
It works particularly well for these hot stars, because what causes the polarization in the star is the electrons, light scattering from electrons in their atmosphere. So you need a hot star. So you wouldn't use this technique for a star like the Sun. It would be too difficult to see the polarization. But it's particularly good for these hot stars, and the hot massive stars are the ones that have proved most difficult to get information out of using astroseismology. So that's where you really need the extra information that polarization gives us.
Yeah, because when I think about it, most of the studies on astroseismology that I've read usually looked at big bloated stars like Betelgeuse and things like that.
Yes, it works, but they're generally lower mass stars.
Yeah.
So it works for stars like the Sun. It works for red giant stars, which are those lower mass stars at the later stages of their evolution. Yes, but it's the hot massive stars are the ones that have been difficult to apply the technique to, and that this new approach helps with.
Combining the three makes it work.
Yes, that's right.
That's Professor Jeremy Bailey from the University of New South Wales. And this is SpaceTime. Still to come. An Astra rocket crashes and burns following a failed launch attempt, its first from Cape Canaveral. And those crowded skies are getting even more crowded with another 34 OneWeb satellites launched into orbit. All that and more still to come on SpaceTime. California-based Astra Space has failed in its latest launch attempt. The mission crashed and burned into the Atlantic Ocean shortly after main engine cut off and first stage separation 4 minutes into the flight. The 13-metre tall rocket had taken off from Space Launch Complex 46 of the Cape Canaveral Space Force Base in Florida. On board were 4 small scientific research satellites. However, the Astra Rocket 3.3 launch vehicle, named LV-008, appeared to begin tumbling out of the sky shortly after second stage ignition. Astra was attempting its first launch from Cape Canaveral following a successful launch from Alaska's Kodiak Island spaceport back in November. That mission placed a dummy satellite into orbit for the US Space Force. 2 previous launch attempts from Kodiak Island had failed due to technical issues. The launch from Cape Canaveral had been postponed twice due to ground equipment and telemetry failures. The payloads aboard the mission, known as Educational Launch of Nanosatellites or ELANA 41, included CubeSats for the University of Alabama, New Mexico State University, the University of California, Berkeley, and NASA's Johnson Space Center. This is SpaceTime. Still to come. It's getting awfully crowded up there, with another 34 OneWeb satellites launched into orbit. And later in the science report, JET, the Joint European Torus Nuclear Fusion Reactor, sets a new world record for energy production. All that and more still to come on SpaceTime. A Russian Soyuz rocket has carried 34 OneWeb broadband internet satellites into orbit. The mission aboard a Soyuz STB rocket fitted with a Frigate M upper stage was launched from the European Space Agency's Kourou spaceport in French Guiana.
This is the first launch of 2022, and we're going to see another 34 satellites joining the 394 already in low Earth orbit. For this launch, we return to Kourou in French Guiana, which is where the very first launch of the OneWeb constellation took place almost 3 years ago, on the 27th of February 2019, with the very first 6 OneWeb satellites. Gosh, what a long way we've come since then. As with every launch, OneWeb is supported by the planning and expertise of Ariane Space. They provided the Soyuz launch vehicles for every mission so far. And not only that, every moment of the launch itself is controlled and monitored by them. From the Jupiter Launch Control Center in Kourou, French Guiana, and back in Ariane Space's headquarters in Évry, France. We're now live with Ariane Space's CEO, Stéphane Israel, from the Ariane Space's headquarters. Stéphane, hello. How are things going in Kourou?
Hello, everybody. Things are going very well from Kourou. We have all our teams there to prepare the launch and the final operations leading to the liftoff, which is now very close.
It is very close, and I'm delighted to hear that everything is going well, because I know this is always a crucial time for you guys. This is the 13th launch and the first OneWeb mission for 2022, but there's plenty more to come, isn't there?
Yes, so this is the first mission of the year for Ariane Space, the first for OneWeb, but we are going to be very busy this year for our dear customer OneWeb, from 2 spaceports, Guyana Space Center as today, but also from Baikonur, Russian Cosmodrome, and we will work a lot for OneWeb.
How is Ariane Space committing to a more sustainable future when it comes to space?
We in Ariane Space are very committed to a sustainable space. The more we launch, the more we go to low Earth orbit for constellations such as OneWeb, the more we must be responsible. For that, in Guyana, we have all the ISO certification, which attests that we limit our impact on linked to space activities. And moreover, we are operating under a unique space law, which is the French space law, which is all about protecting space.
Well, it's great to hear that you have all those systems in place currently. Can you tell us a little bit more about the mission that's actually taking place today in just a few minutes?
Yes, so tonight we are going to orbit 34 more satellites for OneWeb. It will lead the total satellites orbited to 428. These 34 satellites will be separated in 9 different separations during a mission of 3 hours and 33 minutes.
Well, I'm looking forward to seeing it all unfold. And it's not the only thing we've got looking forward to. We're also going to pass a very important milestone, aren't we?
For sure. We are launching Soyuz from the French Guiana tonight, and this launch will orbit more than 100 satellites orbited by Soyuz from French Guiana since the beginning of its operation in 2011. So it is also another milestone we are going to make tonight.
Early this week, the Soyuz VS-27 rocket was rolled into position onto the launch pad, with commentary from Ariane Space's Advanced Studies Director, Vincent Bourdelle.
The first combined operations performed in the Guyana Space Center have consisted in the integration of the complete stack of 34 OneWeb satellites on the frigate upper stage. It has been followed by the encapsulation phase with the fairing installation, so an operation that has been performed half fairing by half fairing. These combined operations have been done vertically in dedicated facilities and clean rooms, and have included, of course, different interface checks, electrical verification, and so on. The last operation performed in the Guyana Space Center clean rooms has consisted in the installation of the OneWeb mission logo on the fairing. 3 days before the launch, the Soyuz 3 stage has been horizontally transferred from the MIC, that is to say the launcher integration building, to the launch pad, as you can see on the video. And once arrived on the launch pad, the Soyuz 3 stage has been vertically tilted, an operation that requires a lot of attention and a very careful managing. And once the launcher was fully vertically set up, the launchpad mobile gantry has been safely installed around the launcher. On its side, the completed upper composite has been transferred to the launchpad and hosted inside the mobile gantry. It has been then integrated and finally prepared on top of the Soyuz 3 stage, and after completion of this installation, the launchpad operation have been initiated with line connection, setup, and different verifications.
Well, thank you very much, Vincent. What we're going to do now is we're going to be hearing from the DDO. Now, he is the person that is in charge of the overall mission, and we're going to be hearing him give his commands. In those last 30 seconds, we're going to have 3 parts to the engines being lit. Firstly, there's going to be the preliminary thrust level. That's then going to be followed by an intermediate thrust level, and finally, the full thrust level. So very shortly.
Attention pour moins une minute.
Okay, so that is the DDO announcing that we have 1 minute till liftoff. The next thing that he's going to give is an instruction for the upper mask retraction. And pretty much straight off the bat of that, he's going to begin the launcher ignition sequence, which is the actual start of the engines being ignited. So we should be hearing very shortly his next instruction. And there we go. That
Largage du Macazedem.
Retracted.
À tous de DDO. Attention pour le début de la séquence d'allumage lanceur.
Amazing stuff. And he will be then going into that beginning of the launcher ignition sequence. So our next thing we're going to hear from him.
20 secondes. Largage du VKM.
Okay, so that is the onboard instruction for the power to start. And we've got the countdown.
7, 6, 5, 4, 3, 2, unité. Décollage VS27 OneWeb.
Liftoff of OneWeb's Launch 13 from Kourou in French Guiana. Now, this, of course, is the second time that the launch has taken place at this precise location. So the first event that we're looking and listening out for is the booster engine jettison. And that's going to happen after the rocket has burnt all their propellant. Once they've completed their burn, the boosters are no longer required. So we are jettisoned to remove weight.
Each of the 150-kilogram OneWeb satellites is equipped with Ku-band antennas and was placed into a 1,200-kilometre high orbit. London-based OneWeb is building an initial constellation of 650 satellites in direct competition to SpaceX's Starlink constellation, which already has over 2,000 spacecraft in orbit and has boasted of plans to eventually have some 30,000 spacecraft orbiting the Earth. A prospect which has angered astronomers who are finding that the satellites are interfering with their important scientific research. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has concluded that previous COVID-19 infection may offer patients a 56% protection level against catching the Omicron variant. The findings, reported in the New England Journal of Medicine, show that prior infection also offers a 90.2% protection against the Alpha variant, an 85.7% protection against the Beta variant, and a 92% level of protection against the Delta strain. The research also showed that the effectiveness with respect to severe, critical, or fatal COVID-19 was estimated to be 87.8% against Omicron, 69.4% against the Alpha variant, 88% against Beta, and 100% against the Delta variant. Almost 5.9 million people have now been killed by the COVID-19 coronavirus since it first spread out of China. However, the World Health Organization says the true death toll is likely to be double that amount, with some 420 million confirmed cases globally. The iconic Australian koala has been officially listed as endangered by the federal government following further declines in its population. The latest drop in the arboreal marsupial's numbers are due to increased human encroachment on its habitat, such as land clearing, and the devastating impact of the Black Summer bushfires in 2019 and 2020. Professor Ewan Ritchie from Wildlife Ecology and Conservation at Deakin University describes the listing of koalas as endangered over much of their distribution as deeply disturbing. He says their demise is emblematic of broader federal and state government failures to sufficiently invest in the conservation of Australia's unique biodiversity. Ritchie warns that without stronger environmental laws, reduction of key threats such as land clearing, which destroys the homes of koalas and many other species, and a substantial increase in funding to support the recovery and protection of these animals, Australia's biodiversity crisis will continue. JET, the Joint European Torus nuclear fusion reactor, has just set a new record for energy production. The facility, located near Oxford in England, delivered stable plasma production using a deuterium-tritium fuel that released 59 megajoules, that's the equivalent of 11 megawatts of energy, during a 5-second phase of plasma discharge, and that's far in excess of its previous 1997 record of 22 megajoules or 4.4 megawatts. Unlike existing nuclear power stations which generate energy through nuclear fission, that is, the splitting of the atom to release energy, nuclear fusion power stations such as JET and its eventual replacement, the now under construction International Thermonuclear Experimental Reactor ITER in France, work by fusing atoms together. It's the same process used by stars. As part of preparations for the new ITER, scientists at JET replaced the previous carbon lining of the plasma vessel with a mixture of beryllium and tungsten. And this allowed them to achieve temperatures 10 times hotter than the centre of the Sun. The problem is, the amount of power required to achieve these sorts of energies is still far greater than what is ultimately generated. Once that ratio is reversed, then a new source of limitless energy will become available. And that's where the new ITER will come in. In recent times, people opposing COVID vaccines have been claiming that the vaccines violate the Nuremberg Code. They say COVID vaccines are experimental, and people have been coerced into vaccination, which breaches the ethical code drawn up after World War II to guide medical research in human clinical trials. However, as Tim Mendham from Australian Skeptics points out, the COVID vaccines have already been tested in preclinical and clinical trials, including phase 3 trials. Their efficacy and effectiveness has been demonstrated, and their side effect profiles extensively examined. Mendham points out that they have been approved for use around the world by medical authorities and so cannot be classified as experimental.
Nuremberg Code was a list of initially 3 and then extended to 10 rules for how you can perform research on people. It follows on from Nazi atrocities during the 30s and into the 40s on people there, often on Jewish people actually, sort of to try and sort of do research on people. Obviously, they weren't particularly cooperative with it. After the war, at least 20 of these researchers were put on trial in Nuremberg, along with other Nazi military leaders and things, about the work that they were doing, these atrocities, and they're pretty horrible things. So a number of people at these trials, or just after it, developed what's called the Nuremberg Code, which was a list of, as I say, 10 rules that you have to follow if you're doing research on people. And the first one is, of course, that the people have to consent to it. You can't do it by stealth or against their will, what was happening with the Nazi researchers. So that was around, it sort of developed a bit. It was actually, the Nuremberg Code was actually dropped in the mid-60s in favour of a different code, which has been itself been through sort of variations, at least 5 over the years, and that the World Medical Association's declaration. So that's what's in practice now. So the Nuremberg Code itself is now defunct, but its place has been taken by something else. The issue is that a lot of anti-vaxxers are saying that people being given the vaccine are research experiments and that therefore they should have their consent to show that this is research. One of the problems with this is, of course, is that research has already been done against and certainly the vaccines have been given approval, especially in the early days, for emergency use. No one gets the vaccine without knowing about it. But the question is it research or is it just treatment? And the suggestion is no, it is treatment. It's not experimental. These things have proved to work. The problem is that some researchers have said, see, these vaccines work. I mean, genuine researchers have used the phrase, the vaccine works. It's been tested 4 billion times, which is not the best thing to say because the implication there is that it's still experimental. But it's not. The Nuremberg Code doesn't apply, despite what a lot of anti-vaxxers and sovereign citizens and people like that are claiming. Yeah, they will still claim it, even though the Nuremberg Code doesn't exist anymore. It's a different code, but it's a handy sort of little code to use. Nuremberg sounds scary, and all these sort of things play into the hands of anti-vaxxers. The thing is, it doesn't apply, and the people that are being vaccinated are not what's covered in the Nuremberg Code.
But they are getting better 5G coverage.
They're getting extremely better 5G coverage, and they're also getting regular updates for Windows.
We shouldn't be laughing at it because the 5%, and we always knew it was going to be about 5% of the population that were never going to be vaccinated because that's what it is everywhere in the world.
Yeah.
That 5% will never be convinced.
It's not just 5% of people who won't be convinced. I mean, there's a few percentage of people who can't get vaccinated because vaccines will hurt them, and that's the immunocompromised people. Then there's the bunch of people who are anti-vaccine and there's nothing you can say to them. And then there's those who are hesitant. The fact that we're reaching up towards, especially in Australia, 95%, 93, 94, 95% of people who have been fully vaccinated, that's the two vaccines,
Which
two
is what
shots.
you always predicted.
Which is, yeah, that's what you basically predict. And that's a huge number. That's probably better than virtually every other vaccine regimen that you could apply. And like all these vaccines, they're not 100% perfect and they're not 100% taken up. And occasionally they need variation as we're getting boosters and things. But it's not experimental at this stage. It's definitely been given with consent. People understand what it is about. It doesn't stop them, anti-vaxxers, quoting the Nuremberg Code, as in fact it doesn't stop them quoting the Magna Carta, which also doesn't apply, or the American Constitution, or the Declaration of Human Rights, which also don't apply, or our Bill of Rights, which is interesting because we don't have one in this country. So, I mean, it's all sorts of things, just terms and ideas that are thrown up there as if they were sort of accurate and that they sound scary and scary enough to convince people who are hesitant. It's just scare tactics on behalf of the anti-vaxxers, and it's dangerous scare tactics, and it sounds sort of like, heavyweight information, but it just doesn't apply.
That's Tim Endham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.